begin with the review from the calculus 1. So here, so I have the graph for fx equal to x cubed minus 2x squared minus x plus 2. So this is a function that I have the graph here. So if you use Google or Mathematica or Wolfram Alpha or any program to draw the graph, you're gonna get the graph of this fx here. So this is the graph of fx. So what you learn in calculus 1, you learn the concept of limit, continuity, differentiation, and integration. This is what you learn from cal 1. So in calculus 1, you learn 4 concepts here, and this is the 4 main concepts that you learn calculus. So you learn how to compute limit fx, where x go to a. This is the notation. For example, if you compute limit fx where x go to 0 here, so this means you're gonna compute limit of where x go to 0 of the function x cubed minus 2x squared minus x plus 2. And this is going to be, well, from calculus 1, if you remember, well, you can use limit theorem, and the limit theorem gonna break out this thing to limit of x cubed minus limit of 2x squared and so on. And then at the end, it's gonna give you the result that is similar to the one that you plug in number 0. So you can think of this thing as 0 cubed minus 0 square minus 0 and plus 2, and at the end you're gonna get number 2 here. So which means limit of fx where x go to 0 is equal to 2. Well, from the picture you can see that at x equal to 0 here, yeah, the function approach the y value approaches number 2. So which means limit of fx where x go to 0 is equal to 2. It does make sense because by the definition of limit, it means you are trying to look at the behavior near number 2. Near x equal to 0. Near x equal to 0, the y value get close to number 2. That's what it's mean by limit of fx. Does it make sense? Well, and also you learn in calculus 1, you learn f prime x. This is going to be your thing called derivative or differentiation. So what you do in calculus 1, you differentiate. You say you can do d by dx, x cubed minus 2x squared minus x plus 2, and this will give you 3x squared minus 4x minus 1, right? This is going to be your fx, and you know how to compute derivative, and if you plug in the number, so let's suppose that you did I do it right? So 1 second, 3x squared minus 4x and then minus 1. Okay, good. Okay, so if I am trying to plug in one number here, so you're gonna see something, you're gonna get the value of the derivative. I'm trying to pick one number for you. Maybe I'm gonna pick, let's see what number is good here. Let's pick number 2. So if I pick f prime 2, so what I'm gonna get is 3 times 2 squared minus 4 times 2 minus 1. If you compute this thing, you're gonna get 3 times 4 minus 8 minus 1, and that is 12 minus 9, and that is number 3. So what does it mean by f prime 2 equal to 3? Well, if you remember in calculus 1, Ajahn Ratinan told you that derivative, the first derivative means the slope, right? The slope of the tangent line. So f prime 2 equal to 3 means at the point x equal to 2 here, the one that I put the laser here now, if you draw a tangent line means you draw the line, touch the curve, just touch the curve. It will not cut the curve, it just touch the curve. For example, I can draw the key line here. This is the one that I supposed to touch the curve at x equal to 2. The line that touch the curve here, this is called a tangent line. Well, f prime 2 equal to 3 tells you that the slope of the tangent line here is equal to 3. So here you're gonna have the slope of the tangent line is equal to 3. Okay, that's what it means when at the point 2 at x equal to 2. This is the definition. I mean, this is the meaning, actually the meaning of differentiation. Okay, and the last thing you learn in calculus 1 is integration. Let's say that you know how to integrate fx dx, right? Well, let's say I am going to integrate from, let's say 0 to 0.5 or 1/2, for example. So what you can do is you can integrate, this thing. Everyone is expert on this thing, I know. The x from 0 to 0.5, and then you can integrate it. So you get x to the 4th power over 4 minus 2x cubed over 3, and then minus x squared over 2, and then plus 2x. And then you're trying to plug in where x equal to 1/2 and where x equal to 0, blah, 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 you get the answer. Well, what you get here, the question mark here, gonna reflect the area under the curve, right? Because you learn in calculus 1 that if you look at the value x equal to 0 up to x equal to 0.5, let's say this one. So the area under the curve is the one that I trying to do the highlighter in green now. If you see the green one that I highlight in the picture, that one is the area under the curve from x equal to 0 to x equal to 0.5. So the meaning of the integration is the area under the curve. In calculus 1, you learn a lot about differentiation and integration. So you know that differentiation is the slope of the tangent line. You have a lot of applications, like, well, you can find the maximum, local minimum. You can use the L'Hopital rule. You can use the derivative to approximate function. You learn a lot of applications in calculus 1. Even the optimization one, you can use differentiation to solve it. Well, in calculus 2, we're gonna learn how to define differentiation in 2 dimensions. And you need a strong background in calculus 1. Because we're gonna use the same formula here, well, you cannot throw away because we're gonna use the same formula here. Well, you're gonna see this week and next week, I'm gonna teach you how to differentiate in 2 dimensions. And also integration in 4 or 5 weeks from now. We're gonna learn how to integrate in 2 dimensions. What interesting about integration in 2 dimensions is what is the meaning of integration in 2 dimensions? Because in 1 dimension, you get the area here. So now you may wonder, Ajahn, what is the meaning of integration in 2 dimensions? So we're gonna learn it. So from area, it's gonna be something else. You're gonna see in few weeks, okay? So I don't wanna scare you, but the content is like gonna be, more complicated compared to Cal 1 because you trying to generalize, you are trying to look at this problem in general when you have more than one variable x. So to keep it clean, we're gonna do only 2 dimensions, x and y. But in general, you can do more than 2 dimensions. You can do x, y, c, w, whatever you can do. As long as you have finite dimension, it's okay. You can look at 4 dimension, 5 dimension, 6 dimension, but usually it's useless in terms of biotech because, usually you work on the problem in 2 and 3 dimensions at the most. So 4 dimension is going to be some space, some abstract space that you probably don't need it. Okay, so let's start by looking at the introduction to multivariable calculus, because as I told you, from now on, what you're going to learn, calculus in more than 1 dimension. Well, let's start by, today I'm not going to touch limit, I guess. I'm going to look at the function of 2 variables first. So let's look at the definition here first. So a function of 2 variables is a rule. They say it is a rule that you assign or map the point x, y into a set D. assign xy in a set D, this is a set D domain, to a unique real number denoted by fxy. Basically, you're gonna start from the domain. So you have the domain here, and you have the point xy in the domain. You send it to a real number called c. And if you define a function like that, it's gonna call function of two variables. It looks complicated in terms of this definition because this is a math definition. But when you look at example, you're gonna feel better about it. So you can see that now. Well, before you have everyone look at this. Before you are familiar with y equal to fx. So you are familiar that x gonna be your independent variable, and you're gonna familiar with y as your dependent variable. So you know that if you plug in x, you can compute y. You plug in x, you can compute y. This is before. In two dimension, we're gonna save x and y for independent variable. So what are you going to do is the input here gonna be x and y. So you're gonna plug in two things, x and y, simultaneously. At the same time, you plug in x and y together. And you need another name for the result. So we're gonna use c. Does it make sense? So in this world, in two-dimension world here, you're gonna plug in x, y into the function. What it return to you, you're gonna get a number. Well, you need to give a name to it. So you name it c. Good. So the function in general gonna be c equal to fxy. Let's take a look at example. So example 1 here. So let's find and sketch the domain of the following functions, and also you compute f11. So you see here, this is a function of two variables, fxy. So you need two inputs. Input number 1 is x, input number 2 is y. And after you plug in x and y to this function, you're gonna get one number after you plug in that thing called c. Well, you don't see the number, the output yet, but here the question asks you to find the domain and sketch it first. So let's find the domain of this thing. So the domain, you remember the domain? The domain means any number that you plug in and it does make sense to the function. So basically the question is, what are x and y's that you plug in and it makes sense and it is computable and it's, you know, legal that you can compute it. So for here, we learned since high school, or you know, since the AP test, the thing that you took before that, well, under square root, you cannot have negative numbers, right? So the thing that you need to be careful here is, well, you know from your kid that under square root sign, if you see things under square root sign, it means that the under square root sign here need to be greater than or equal to 0, right? We're gonna use this trick always. When you see something under square root, that means that thing needs to be non-negative. So from here, we're gonna have, well, it must be the case that 6 minus x squared minus y squared greater than or equal to 0. Because it is, you know, under the square root sign, because it must be greater than or equal to 0. If you move thing around, so you're gonna get 6 greater than or equal to x squared plus y squared. I move x squared plus y squared to the right hand side. And if I draw the graph, so well, if you simplify it, you're gonna get x squared plus y squared less than or equal to 6. Okay, this is a circle, right? Everyone know that x squared plus y squared is the circle center at the origin. So basically, if you draw the graph, this is the y-axis, this is the x-axis. So the domain gonna be the circle. Well, this is the circle. What is the radius? The radius is square root 6, right? Because x squared plus y squared less than or equal to 6. This is a circle radius square root 6. So square root 6, negative square root 6. And then you draw a circle here. And here, the area under the area inside the circle here, this is the domain. right? Because we are looking for all possible x, y such that x squared plus y squared less than or equal to 6, which means inside the circle here. Sounds good? So which means, well, I can answer now that the domain is gonna be all possible x, y such that x squared plus y squared less than or equal to number 6. This is our domain for this question. And if you want to draw a picture, this is the picture. Because any number in this area makes sense. If you plug in, you can compute it. For example, if you plug in F11, so because the question asks you compute F11, so you just plug in number 1 here, 6 minus 1 square minus 1 square, you get square root 4, and that is 2. Yeah, makes sense. It's mean if you plug in number 11, which is 1 point in this here, if you plug in number 11, you get 2. Yeah, good. But if you plug in the number that is outside domain, it does not make sense and it is not computable. It is, you cannot compute it. For example, if you plug in like 10, 10, this is way out of your domain. If you plug in, you can try, if you plug x equal to 10 and y equal to 10, it's going to be impossible to compute because under square root sign, you're going to get negative thing. Well, hopefully you feel more comfortable with the function in 2 dimensions. Well, the idea is you plug in x and y. So you get one number. The output gonna be one number. And x and y that you plug in must be something that, be in the domain. So it makes sense to compute. All right, so example 1.2. So another caution here, if you see logarithm, this is the one that also have the restriction. After logarithm, what you can put after log here, gonna be the positive thing, right? So if you see logarithm, it means the thing after logarithm here need to be positive, because the thing after log need to be positive. You cannot put something negative inside the logarithm over there. So now you have, because of this, you have x squared plus y minus 1 greater than 0. And that's mean, well, x squared plus 1 greater than y, and that means y less than x squared plus 1. So you need to draw a graph of y equal to x squared plus 1. And everyone know this is parabola, right? For those of you who don't know how to graph this thing, you can draw y equal to x squared first. This is, well, I'm gonna use the green pen here to draw y equal to x squared here. This is y equal to x squared. If you wanna draw y equal to x squared plus 1, how would you do it? So that means you have to, well, y equal to x squared plus 1, it means you shift the graph, right? Shift the graph. So before you have, well, 1 second, if you have x equal to 0, gonna be y equal to 0, right? And then if you add 1 here, so it means when x equal to 0, you're gonna get y equal to 1. So which means add 1 here, so you shift the graph up 1 unit. This is from, from basic function that you learned when you were kids, right? So here, I'm gonna just move 1 step up. Gonna be that one. Whoa, this is parabola. So I didn't use the ruler, so this is a little bit odd, but here, this is y equal to x squared plus 1. Okay, and because you don't include the equal sign here, so you can do some dash line. So it means you do not want to include that line. That one, okay? Y equal to x squared plus 1, but you do not want to include that one. So you are looking for the area such that y less than x squared plus 1. So it must be the case here, right? All the area here gonna be the area that y less than x squared plus 1. So if you want the area above, the curve here, this is going to be the area that y greater than x squared plus 1. Does it make sense? So which means the area that you have to shade, it's going to be the outside one. Yeah, this is all the area you need for this question, because you want the domain here to be x, y, such that y is less than x squared plus 1. And if you want to compute f11 here, it's going to be log 1 squared minus 1 plus 1. And that is a log of 1. And that means 0. So if you compute log 1, it means you try to compute 0. Oops. Something was wrong. Sorry. 1 second. Need to share screen again because I think I hit some button. Okay. All right. Any question on this example number 1 here? We spend 10 minutes on this example because this is the first step that you're going to learn function in 2 dimensions, and hopefully you understand it. It's like give you the idea that for function of 2 variables, you need to plug in x and y, and this is how to plot the domain. This is how to get the domain of the function. You may have a question that why do we need to study this thing? Why do we need to study function in 2 dimensions? Yeah, because in one dimension it's not going to be generalized, which means in terms of application you don't have a flexible thing to use. So you can use only the line, the parabola thing. It's like not good. In 2 dimensions, you're gonna have x and y as your input. And once you get it, once you draw the picture, so the function of 2 variables f, x, y gonna give you a surface, not just a line. Does it make sense? Well, we're gonna see it on the next slide. So can I pass this slide? Go, okay. All right, so next we're gonna look at the surface here. So keep in mind that the geometric interpretation of fxy, this is the surface. What it means is like, yeah, I know this is my function fxy. If I plug in x and y here, so I'm gonna get 1c equal to fxy. Yeah. But if you draw fxy, it's gonna give you a surface like that. If you draw a function gxy here, it's gonna give you a surface. Which gonna give you more thing to use in applications. Let's suppose that you go to the camping one and you want to find the equation that describe the tent. For example, this is like maybe this is a tarp or something that you use to build a tent. So this thing can be described as an equation for x squared plus y squared. So the equation for this picture gonna be c equal to 4x squared plus y squared. This is the equation that describes this picture. You can see that it's a little bit more complicated compared to what you know before, because you have x, you have y, and you have c. It is actually represent now in 3 dimensions. X and y are your input and c are your output, and then you get this picture. Compared to what you learned before, when you were a kid, like c equal to 4x squared. You're gonna have y equal to 4x squared when you were a kid. So it's going to be just the plane. Your whole world gonna be the plane x and y, and y equal to 4x squared is just a parabola. This is all you can do in 1 dimension. It's just a picture with a line. You will never have a plane or something. But for 2 dimensions, you're gonna have more thing to do, more thing to work on, more complicated stuff to work with. Well, keep in mind that to graph a function, you must have 1 dimension more than a number of independent variables. So in function of 2 variables, you need 3 dimensions. So it's gonna be here. So if you have x, y, and z as your independent variable, you're gonna need 4 dimensions to plot it. which you cannot see in the picture here, because 4-dimension is going to be a lot harder to draw because you have X, Y, Z, and you need to have another axis. Maybe you're going to use palm as the axis, because in the aerospace engineering, they use 4 dimensions because they believe that our world, you know, the surface of our world, it's going to be 3 dimensions already, but they need the time as another dimension. So if you study some astronomy or something like that, you're going to need to work with 4 dimensions. But here 3 dimension is enough. So we're going to look at X, Y, and Z here. So you can get picture here. Well, it is impossible in general for you to draw this thing by hand. We're going to use computer to draw it in general. So in real life, if people comes to you and, hey, grab this one, well, always use computer. It's ridiculous that you're going to graph it by hand. Impossible. So for example, if you want to draw sine X plus sine Y, it looks simple, but I do not recommend to draw it by hand. It's impossible. Even me, I cannot do it. So when you do this thing, put it in computer, you're going to get a graph here. Because this is not in 1 dimension. It 2 dimension or more, we have computer, or we have a software. Why don't you put it in the software and get the answer? Here, this is the graph of sine X, sine Y. It's beautiful, right? It's like the wave thing here. So this is sine X plus sine Y. This is sine X times sine Y over XY. It's going to be this thing. So basically, I told you that, hey, in order to get a plot of the function, you need a software. So the software that you can get it easily is like Mathematica or Wolfram Alpha. If you go to wolframalpha.com, just Google it, wolframalpha.com, and then you put this function into Wolfram Alpha, you're gonna get this picture, and that will be the picture of sine X plus sine Y. Interesting. So in terms of calculus, actually you can draw some function of 2 variables as well. We're gonna take a look at example to show you how to draw function of 2 variables. I'm gonna show you this example because it is easy to do it, but you know, this is going to be the only example we do in this class. But I will not test you how to plot the graph because I would recommend you in real life to use software or computer. But if you want to do it by hand, this is the way to do it. Just take a look, you know, take a deep breath, and this is just the way mathematicians do. But you know, if you do not understand, fine. If you do understand, good, very good. So I'm gonna show you how to draw fxy equal to x squared plus y squared if you want to draw it by hand. Okay. Suppose I want to sketch this thing by hand. What should I do? So first of all, I'm gonna say that, okay, I need a domain. So the domain is X and Y here. It can be anything. X, Y can be anything. So I can plug in X, Y, anything I want. Good. And after I plug in X and Y here, when I compute it, this is going to be greater than or equal to 0 for sure. Because of what? Because this thing is square. So when you have square, this means this thing gonna be non-negative, this thing gonna be non-negative, and you add them up, it's gonna be non-negative as well. Good. So this is the basic thing that I know. Okay. Now I want to sketch it. What should I do? So the idea is so simple. So you're gonna start from, let's take a look that when, well, this is equation C equal to x squared plus y squared, right? So let's take the idea. Let's suppose that when C equal to 1. So what happened when C equal to 1? So you get x squared plus y squared equal to 1. Oh, actually when C equal to 1, it's just a circle, right? It is just a circle, radius 1. Fine. So let's suppose that when I have C equal to 2, what happened? When C equal to 2, you're going to have x squared plus y squared equal to 2. Also circle, but the radius is bigger, right? So you're going to have that circle again. But the radius is a lot bigger, so this is square root 2. Okay, good. But you know the center is going to be the same at 0, 0 here. But the radius just keep getting bigger. As long as you increase your C value here, the radius is going to be bigger, bigger, and bigger. Well, if I plug in c equal to negative number, it's gonna be x squared plus y squared equal to negative number, which is impossible. So, which means you cannot plug in c equal to negative value. You can only do the positive value. Okay, let's draw it. This is the c-axis. This is the x-axis. This is the y-axis. So, take a deep breath. This is c equal to 1. So I want to plot circle here. So I'm going to hit c equal to 1 here. If you want to look at that, I'm going to hit c equal to 1 here. It's going to look like you have another plane here at c equal to 1. And you're trying to draw the circle over there, which is a circle of radius 1 here at c equal to 1. Well, this is in 3 dimensions, but you know, what you saw now on my iPad here is 2 dimensions, but actually the circle I draw here, this is in 3 dimensions now. And also when c equal to 2 here, so it's going up. Well, I get circle as well, but the circle is getting bigger. The radius is getting bigger. So I'm going to have that. And well, believe me, if you do 3, 4, and so on, so you also get the circle, right? Because you're going to get the same equation, but you're going to get a circle with bigger radius. So it's you're going to keep getting circle here. Well, maybe this circle, I need to be better on drawing the picture here. This is c equal to 2. This is c equal to 1. And if you get all the picture here. So, well, at c equal to 0 here, it's going to be just a point because this is x squared plus y squared equal to 0. It's going to be just a point here. And on the negative side of c here, I have nothing because you cannot put negative value of c here. If you connect all the dots, you're going to get this picture. This is actually c equal to x squared plus y squared. This is going to give you some picture like a cup, and this is called paraboloid. Right? So it's going to be something like, not easy to graph, but if you understand it, good. If you do not understand, fine. But well, basically, as I told you, you have a software that you plug in this thing. Well, if you can try plug in x squared plus y squared, boom, they're gonna give you like some paraboloid here. Well, question from student, why c can be negative? Because c equals to x squared plus y squared. It cannot be negative because this is gonna be non-negative always. Right, and this is gonna be non-negative always. You believe me? Because it is square, and then you add 2 things together, it's gonna be always non-negative. Yeah, this is why. Well, there are a lot of things that you can do about this thing. Well, if you, let's suppose that if you do c equal to square root x squared plus y squared, it's gonna be the same pattern. But if you take square root, just take square root, okay? This is gonna give you a picture like a cone. A cone. Here, something like that and that. This is a cone. The shape of the cone here gonna be this function. Well, if you are interested in this thing, well, you can take more math class. But for this class, I'm not going to test you how to draw a graph, but I need to give you an idea about this thing first, because some of you are curious a lot about why do you need to learn this thing. Actually, the thing that you learn here now, this actually in real life, it links you to the surface here. And when you study the behavior of this function, you're trying to study what you can do with this surface. Let's say like if you have this picture like in real life, and you want to fit this you want to design the experiment that you want to fit the plan going by using this function. For example, you want to decide the plot using this function. Well, what if I want to make the top part here just chip down by 1? How would I do with this equation? Or how can I find the slope at this point? Or how can I find the volume under this surface? You can get a lot of information from this picture by using differentiation and integration. Of course, it's going to be complicated because you have 2 dimensions now. Well, we're going to wrap up the class today by looking at overview for the remaining of the course. Well, the content for today, I need to summarize again. So the content for today, I teach you how to draw the graph of fxy, and I teach you how to find the domain of fxy. I want you to get familiar with fxy, but actually what you're going to learn, we are going to forget about that picture, because this is a picture. Well, now you have in your head that you learn fxy because it linked to a surface, which you have a lot of applications in real life starting from that surface. What we're going to do is we're going to learn limit, differentiation, and integration with this function fxy. I want to give you the overview how hard it is so you can connect it with the thing that you learn in calculus 1. So limit. Why is it hard to define limit into dimension? If you remember, in calculus 1, you used to learn something like, hey, Ajahn, this is the point x equal to a. In calculus 1, you learn left hand limit, right? This is called left limit. Okay, because in calculus 1, when you learn limit fx, x going to a on the left. You learn this thing, and you also learn line limit in calculus 1. You learn limit of fx where x go to a from the right. This is two different notation. X go to a minus, this means go to a from the left, and x go to a plus, this is go to a from the right. If they are equal to each other, yes, bam, limit exists, and that is the answer, limit equal to L. Good. That is what you learn in Cal 1. You can see how hard it is in 2 dimension. Let's suppose that you have x and y here. Let's suppose the point is not going to be x equal to a. It's going to be xy equal to ab. Wow. How would you do it? Okay, you have left hand limit. Okay, you have right hand limit. You have up limit. You have downside limit. You have any line that approach here. How would you define limit then? Because it is not in 1 dimension that you have x equal to a and you only have left hand and right hand. Here you have so many lines that you can approach the point AB here. It's gonna be harder to define limit in 2 dimension because you're gonna have limit fxy, and what you are looking at is xy going to a, b. It's gonna be x going to a, y going to b. And here you can go from this line, by this line, or any line, as I told you, as long as it approach the point AB, should consider as limit 2. Well, we're gonna talk about this thing on Wednesday. How do we fix this concept? And how do we define that limit? How do we compute the limit at the point? Because the limit gonna be the basic thing that you're gonna use it to define differentiation later. And after that, we're gonna define differentiation. As I told you before that, when you have fx, it's gonna be easy to compute d by dx because you know already that your variable of interest is just x. In 2 dimension, you're gonna have fxy here. Let's say the easy function x squared plus y squared here. Well, of course, when you differentiate in 2 dimension, so I'm gonna tell you let's look at the sneak peek of this thing. So when you differentiate with respect to x for in 2 dimension here, what people do is, let's think that y is constant. So when you write this notation d by dx. So we're going to switch the notation a little bit. So we're going to, instead of using d, we're going to use some notation curl here. Curl mean we're going to differentiate anyway, but we're going to differentiate with respect to x, which mean we're going to view that y to be constant. So which mean when you differentiate this, so you differentiate x squared, you're going to get to x. You're going to get what? You're going to differentiate y squared, you're going to get 0. Because now you're trying to integrate, you're trying to differentiate with respect to x. So anything that is not x, you treat it as constant. So it's going to be 0 because you treat y squared as a constant. And then you just differentiate x squared, so you get to x. Well, with the same concept, you can have fxy and differentiate with respect to y. This means you're going to get 0 plus 2y. Because you treat x as constant and you treat y as, a function that you are interested in. So this is how we define differentiation in 2 dimensions. We're going to learn this thing next week. And, you're going to learn how we use the chain rule, how we use the product rule, anything that you learn in Cal 1. So it's going to repeat again. And we're going to look at, okay, if it is in 2 dimensions, what is our approach? Can we do like we did before in Cal 1 or something like that? Integration as well, that you have double integration as I told you. That is going to be the x dy here. The notation looks scary because you have double integration, but actually it's going to be the same concept with differentiation. If you want to integrate with respect to x, you're going to treat y as a constant. If you want to integrate with respect to y, you're going to treat x as a constant. That is the basic thing. So we're going to learn this thing, I think after Songkran. So we're going to hit to integration part. Okay. So on Wednesday, we're going to come back to look at limit first. So as I told you, the thing that is interesting for limit is that now you can approach the point from any line. How would you do it? Well, let's take a sneak peek on what we're going to learn next class. For example, this thing, you have this function, let's say fxy. This is a function. Let's suppose that you want to find limit of this function near the point 0, 0. Let's say I want to find limit of fxy where xy approach 0, 0, right? So you can see that the point 0, 0 is here. When they approach 0, 0, everything like, oh, the limit should be 1 because from any direction, the value that you get close to 1. So this limit exists and equal to 1. But for this function, different one. So you can see if you approach from the left, the limit is -1. If you approach from the upside, you're going to get 1. If you approach from this, which is you approach from the line y equal to x, 0, 0, 0, and so you have limit from the left hand side is -1, limit on the upper upside here is 1, limit from y equal to x is 0. In this case, you're gonna say limit does not exist because you have different limits on different lines. Yeah, we're gonna learn this thing on Wednesday. Make sense? So hopefully you see a big picture of what we're gonna learn. And the example that I will give you, it's gonna be totally enough for you to study and cover on the exam. So you don't have to find another example or harder example other than what I teach in class, because the exam gonna be something like I show you here on the practice problem. If you can do all the practice problem, you can do the exam for sure.